Hi, today we will learn Vogel's approximation method. It's another initial feasible basic solution finding method, just like northwest corner rule and least cost methods which we earlier saw. Vogel's approximation method is very logical, more logical than northwest corner rule and least cost method, since it uses penalties. It calculates penalties and then decides which route to be allotted, how many units. Now the penalties are calculated by picking the least cost route and the next least cost route in each column and each row, and then finding the highest of these penalties. The logic is like this, that let me write first iteration here. Now I'll find the difference between the least cost and the next least cost, which is 1 here in this for this row. Now what it means, what this 1 means actually is that if by chance if I miss this least cost route and have to pick the next least cost route, the penalty which I have to pay is 1 rupee extra for every 1 unit shipped through Bangalore to Hyderabad than instead of Bangalore to Cochin. So my cost increases by 1 rupee. So I would not like to miss this least cost route. So I'll find the penalties for each column and each row, and pick the highest penalty column or row. Now in this row it is 3 minus 2, 1. In this row it is 4 minus 2, 2. The penalty is 2. This is also called as penalty method because we calculate penalties and then decide which route to be allocated how many units. Now in this route it is 5 minus 3, 2. In this route it is 2. In this route it is 5 minus 2, 3. In this route it is 3 minus 2, 1. Now among all these penalties we can see that this is the one with the highest penalty. Now I'll pick this column, and then in this column I'll pick the least cost route and then ship as many units as possible from Bangalore to Cochin. In this case it happens to be 4,000, so I'll ship entire 4,000. The logic is that if I suppose miss this route, least cost route, and if I have to pick the next least cost route, the penalty which I have to pay is 3 rupees extra for every 1 unit shipped, which means that it will be coming around 12,000 rupees for 4,000 units being shipped. To avoid that, I'll ship as many units as possible from Bangalore to Cochin and not miss this route. I'll use the similar logic for the second iteration and then calculate the penalties. After finishing this column, this Cochin's requirement is fulfilled, so I'll cancel this out. I'll just use the red color and then cancel this Cochin. Now calculate the penalties for the second iteration. Now again I'll use the same logic, that is 6 minus 3. I'll change this to yellow color. Yeah, 6 minus 3 is 3 penalty. 3 minus 2, 1. 4 minus 2, 2. Column wise it doesn't change because nothing will alter here since we have cancelled a column. 3 minus 2, 1. 4 minus 2, 2. 5 minus 3, 2. In this second iteration, this is the one with highest penalty. I'll go along this row and then pick the least cost route, which happens to be Bangalore to Hyderabad, and fill as many units as possible. Now Bangalore to Hyderabad I can fill 1,000 units because Bangalore's capacity is 5,000. 4,000 we have already shipped, so 1,000 more left with Bangalore plant. I am shipping entire 1,000 units from Bangalore to Hyderabad. After shipping 1,000 units, this Bangalore's capacity is exhausted, so I'll cancel this using red marker. Now I'll calculate the third iteration in similar manner, penalties. So since this is over, I'll just cancel this out, ignore this. Now for Chennai it doesn't change because we have cancelled a row, so it will be same 1, 2 here. It might change column wise. 5 minus 3, 2. 4 minus 3, 2. 4 minus 2, 2. And this is ignore. 7 minus 2, 5. So this is a huge penalty, so I would not like to miss this least cost route here in this column. So fulfill So ship as many units as possible from Delhi to Hyderabad. In this case, 2,500 units, which is Delhi's capacity. After shipping 2,500 units, cancel this row. Now I am left with Chennai row, and I don't have any other alternative since I cannot calculate penalties anymore. So I'll fill this with the balance remaining units. Now balance remaining units happens to be, uh, if you are saying this 6,000 units. So in this least cost route is this one. I'll fill 2,000 units here. The next least cost route is 3 here, 1,500 units, and the balance I'll ship 2,500 units here. So this is 6,000. Check for rim requirements. Rim requirements is this, the requirements of distribution centers and supply should be matching. So 4,000, 4,000, 2,000, 2,000, 1,500, 1,500, 6,000 this side, 6,000 this side, 5,000 this side. So everything is, the rim requirement is met with. Now after calculating this, after finding the initial basic feasible solution, you can see that we have got 6 basic variables: 1, 2, 3, 4, 5, 6 basic variables. Now check for degeneracy. Checking for degeneracy involves checking for m plus n minus 1 basic variables. M stands for number of plants, n stands for number of distribution centers, that is destinations, minus 1. 3 plus 4 minus 1, 6 basic variables. We have got 6 basic variables. After checking for degeneracy, we know that we are not entered state of degeneracy. After that, we calculate the total cost. Total cost is calculated just the way we calculated total cost for other methods, that is 1000 into 3. I'll just calculate this fast. 1000 into 3, 3000, and 4000 into 2. $42,000. Thus the end of Vogel's approximation method. Hope you liked this. If you liked, press like button. Thank you very much. Good night.